Vernier calipers consist of a graduated bar with a fixed jaw and a sliding jaw. The bar has the main scale and the sliding jaw has the vernier scale.
The main bar of the vernier caliper is measured in inches or millimetres. The vernier scale is a more precise measurement. The main scale is twice the size of the vernier scale, which has been divided each 1 mil into 20 sections. This shaft is scored and worn and either should be replaced or repaired.
Measure the lobe from the top and bottom with the verniers. Now measure from side to side on the same lobe.
Now subtract both measurements to get your camshaft lift and lobe surface.
Journal diameter measurements.
To get your journal diameter, measure both ends of your shaft as shown in the picture. A dial gauge is marked with divisions of 0.01mm. A pointer operated by a plunger moves around the face of the gauge, which then operates another smaller pointer, which counts every rotation in 1mm division. When using a dial gauge, be sure the magnetic surface will not move. The dial gauge is used to check straightness of shaft sitting in V-box. We are measuring the crankshaft the same as we measure for the bent camshaft.
The main measurements on a micrometer are located on the sleeve. The thimble then shows the more precise measurements going up in 0.01mm. When set at 0, this micrometer should read 50mm. When placed in this measuring device, there should be no gap. If so, it can be adjusted accordingly.
When using a micrometer, hold the plastic bit so body heat is not transferred, giving you a wrong reading. To perform journal taper and out of roundness check, you must use an external micrometer.
Hole gauges are used to measure the diameter of holes, slots and recesses. Both arms either end can either be compressed or extended according to the size of the hole that needs to be measured.
To measure camshaft pushings, you must use a hole gauge.
This micrometer consists of a head and a replaceable spindle. It is read in a similar manner to the outside micrometer, using scales on the thimble and on the sleeve. Place micrometer in the bore and expand it until the anvil and spindle are in contact with the wall. Move up and down and side to side slightly. To check the warpage of a cylinder block, use a straight edge and feeler gauges as shown in the picture.
When checking for piston ovality and diameter, you must use an external micrometer. When mounting rings to a piston, be sure not to align the 3 gaps in the rings and use the correct tool. Measuring ring depth on a piston must be used with a vernier depth gauge. To check ring side clearance, use your feeler gauges and insert above your ring.
To get height protrusion of the sleeve, set the dial gauge up so it runs across the block and the sleeve.
Be sure to bolt the sleeve down using large washers and head bolts. When using plastic gauge, make sure you install it central to what you want to measure.
Torque bearings to manufacturer's specifications. Loosen, then read plastic gauge with the indicator.
To check crankshaft end plate, set dial gauge up on motor and read dial from crank movement. When checking oil pump backlash, use a feeler gauge and insert it between the meshing gears.
Side clearance can be checked using a feeler gauge from the top of the gear to the outside of the housing. To measure the end clearance, use a straight edge across the gears and a feeler gauge underneath to get your clearance. Radial run out is checked with the dial gauge set on top of the flywheel as shown in the picture.
Visual check of a flywheel includes checking for face warpage, heat checks, scoring and teeth wear.
Actual run out is checked with the dial gauge set on the front of the flywheel whilst it is spinning. The alignment lugs are checked with a tri-square to make sure that the lugs are straight and not bent. Infrared thermometers. This is a metal emissivity table.
The main advantage of a non-contact infrared thermometer are speed, lack of interference, the ability to measure in high temperatures in ranges up to 3000 degrees Celsius. Keep in mind only surface temperatures can be checked.
Emissivity is the measure of an object's ability to emit infrared energy. Emitted energy indicates the temperature of an object. Emissivity can vary from 0 to 1. Rocks, wood, plastic, rubber have surfaces that reflect very little and therefore have high emissivity between 0.8 and 0.95.
This picture shows the spot compared with the target. The optical system of an infrared thermometer picks up the infrared energy emitted from a circular measuring spot and focuses it on a detector. The target must completely fill the spot, otherwise the infrared thermometer will see other temperature